that is note. Note, that is a CT point, very important. First one, let 1 by I value is what? Let 1 by I value is what? 1 by I, here division of complex, denominator form, division of complex. Here apply one value or rationalization. Rationalization. Do you know that rationalizing the function, denominator, that is I, multiply and divide with opposite sign. Here multiply by minus I, divided by minus I, plus becomes minus, rationalizing the function. That is, multiply numerator, multiply denominator, 1 into minus I, plus minus I square. Next minus get cancel. Don't get cancel I, 1I. Here numerator I as it is, denominator I square. Do you know that previous class I square value minus 1, I cube value minus I power 4, 1. These three values are very important, keep in your mind. That is, here I square value is what? Minus 1. Plus I by minus 1, value is what? Minus I. 1 by I value is what? Minus I. Keep in your mind this point. Here 1 by I value, division of complex, denominator I, by apply rationalization, this function, multiply by minus I, divided by minus I. Numerator multiply, denominator multiply. 1 into minus I into I square, plus minus get cancel. Numerator I as it is, denominator I square value is what? Minus 1. Plus I by minus 1 is what? Minus I. 1 by plus I is what? Minus I. Next, suppose 1 by minus I value is what? Suppose 1 by minus I value is what? Same as it is rationalizing the function, that is 1 by minus I as it is, by apply rationalization. Here denominator which function? Minus I is there, minus I becomes plus I by plus I. Apply rationalization. Next multiply numerator, multiply denominator. 1 into I. 1 into I is, that is numerator, 1 into I, denominator minus plus minus I into I square value. Here I square value is what? I square value is what? Minus 1. That is minus, keep as it is, I square value minus 1. Minus plus is equal to what? I. Therefore 1 by minus I is what? 1 by minus I is what? Plus I. Here these two solving not necessary, keep in your mind. 1 by plus I is what? Minus I. 1 by minus I is what? Plus I. These 2 points keep in your mind. Then next solve the examples for iota I power n, n means positive integer, positive integers over, next negative integers, solving the negative integers helps these two values. Next, negative integers, suppose n is negative integer, powers, I powers negative values or negative integers is what? Uh, 1 by plus I is equal to value minus I, 1 by minus I is equal to plus I points. Next, evaluate first one, I power minus 50. Suppose plus 50 is there over minus 50 is what? I power minus 50. This can be expressed in the form of, here convert value, 50 convert smallest is there. I power minus 50, negative integer is there. Negative becomes positive. Here power is negative, here there is no value, convert positive. We know that a power minus n can written 1 by a power plus n by the law of indices, that is keep in your mind, a power minus n is equal to 1 by a power plus n. I power minus 50 can written I power plus 50. Yes. Remaining as usual previous method, 1 by convert smallest I power 4 divided by 4, 4 into 12, 48, remaining I powers is what? 2. Remaining I powers is what? This value always what? I power 4 is 1. 1 to the power any number, 1 to the power 12, 1. Next, continue. 1 divided by 1 into I square, value is what? I square. I square value is what? Minus 1. 1 by minus 1 is what? Minus 1. 1 by minus 1. This is not I, 1. 1 by minus 1 is what? Minus 1. Next, example number 2. That is I power minus 100. I power minus 100. Negative integer is there, make it positive integer. 1 by I power plus 100. Next, find the value of I power 100. I power 4 whole to the power 25, round the number. Remainder not necessary. 1 by 1. 1 by 1 is what? 1. 1 by 1 is what? 1. Any doubts? I power minus 50 is there. Negative integer. Here there is no solving procedure. Make it positive. Here minus 50 becomes plus 50. 1 by I power 50 by the law of indices. A power minus n becomes 1 by a power n. Here plus 50 as usual method is there. Here I power 4 whole to the power 12. 12 into 4, 48. 48 remaining is what? 2. I square. Bases are same, power should be added. Next, 1, this value is 1. 1 into I square is what? I square. I square value is what? Minus 1. 1 by minus 1 is what? Minus 1. Here 50 can return 4 12s are 48. Remainder is what? 2. Otherwise, here I power 50 can written in another form. I power 4 m plus r. 48 plus 2. By the law of indices, this can be written here 4 12. 4 12 by the law of indices into I square. By the law of indices, 4 into 12. Here 4 whole power 12. Law of indices, do you know that law of indices? A power m n can written a power m whole power n. A power m whole power n can written another form. If this is a power m plus n can written a power m a power n. That is law of indices. Here another one law is there. A power m plus n can written a power m into a power n. A power m plus n can written a power m a power n. Here note a power m plus n can written a power m a power n. Separate for the powers by the law of indices. Separate for the powers. Any doubt? Okay. Next values, negative integers. Suppose I power, example number 3, I power minus 35. Find this one or evaluate. This can be written, make it positive first, 1 by I power plus 35. Yes, plus 35, solving the procedure, 1 by I power 4. 4 8s are 32. Here 35, 4 8s are 32, remainder 3. This is m, this is r. 4m plus r. Remaining is what? Cubic. This value is what? Always 1. 1 into I cube. 1 into I cube. Here I power 4 is what? 1. 1 to the power 8, 1. Only present I cube. I cube value is what? I cube value is what? Minus I. I cube value is what? Minus I. I cube value is what? Minus I. Yes, note number 2, note number 2, 1 by minus I is what? Plus I. 1 by minus I is what? Plus. Yes, that's the reason. Here that's the reason. 1 by minus I is what? Plus I. Yes, this form exists. Refer note number 2. That is, note is what? 1 by minus I is what? Plus I. Suppose 1 by plus I is what? Minus I. That reason here 1 by minus I is what? Plus I. Next, example number 4. That is I power minus any value. I power minus 9. This value, make it positive, 1 by I power 9. 1 by I power 9 can return 4 2s are 8. 4 2s are 8. Remainder 1. 1 divided by I power 4, 1. 1 to the power any number? 1. 1 into I. Yes. 1 by I. 1 by I is what? Note number 1. Just previous. Note number 1. 1 by I is what? Minus I. 1 by I is what? Minus. Because here because 1 by I is what? Minus I. 1 by minus I is what? Plus I. 1 by plus I is what? Minus I. 1 by minus I is what? Plus I. Here 1 by plus I becomes minus I value. Note number 1 I. Any doubt? Clear? I power 4. Just homework. Fifth one. I power minus 19 in your homework. Sixth one. I power minus 2020. Here keep in your mind I power 2, I square value minus 1, I cube value minus I power 4 is equal to 1, that is here base 4 convert value is solved. Here once again I will explain this one. I power minus 35, negative integer, not a value, make it positive. Here minus 35 becomes plus 35. Here plus 35 is there, split convert smallest value in the form of base convert 4, 4 8s are 32, remainder is what? 3, separate for the remainder is separate. Here base is I, remainder is separate. This value always 1, I power 4, any number is there always 1, because I power 4 is what? 1, I power 4 is always 1. Next I cube value is what? I cube value is what? Minus I. Do you know that? Previous class I cube value is what? Minus I. I cube value is what? Minus I. 1 by minus I is what? 1 by minus I is what? 1 by minus I is what? Plus I. Yes, 1 by minus I is plus I. That reason I write the direct note. Next I power minus I. Make it positive, plus I power minus 9. Make it positive, I power plus 9. 4 2s are 8, remainder is 1. This value always 1. 1 into I. 1 by plus I is what? 1 by plus I is what? Minus I. Refer note. Clear? In the annual examination, direct one understood. Here as practice, 1 by plus I is minus I, 1 by minus I is plus I, 1 by minus I is plus I, 1 by plus I is minus I. Next here complex numbers, addition, subtraction or difference, multiplication of complex numbers, division of complex numbers. Here algebra on complex numbers is there. Algebra on complex numbers. Algebra on complex numbers. Let two complex numbers defined, Z1 is equal to A plus IB and Z2 is equal to C plus ID, be two complex numbers. Complex numbers. One by one. First one, addition of two complex numbers. Addition of two complex numbers. Addition of two complex numbers. Z1 plus Z2 is equal to addition of two complex numbers. Add two complex numbers. These two add it. A plus IB plus C plus ID. Addition, here real part one side, imaginary part one side. Real add it, A plus C, these two are reals. Imaginary I taking common, B plus D. Yes, real part separate, imaginary part separate. Addition. Example, suppose example, let take two complex numbers, z1 is equal to 2 plus 3i, one complex, and another one complex take z2 is equal to 1 plus I. Any complex, 2 plus 3i, 4 plus 3i, whatever, two complex numbers. Addition of these two complex, z1 plus z2 is what? 2 plus 3i plus 1 plus I. Add real, add imaginary. 2 plus 1 plus I taking common, 3 plus, here I is there, its imaginary part is what? 1. This is 2 plus 1, 3 plus 1. 2 plus 1 is what? 3 plus I as it is. Here I taking common 3, here I taking common 1. 3 plus 1, 4. That is 3 plus 4i. That is addition of two complex. Here otherwise you direct add it. 2 plus 1, 3. 3i plus 1i total 4i. That is also here. That is addition of two complex numbers is there. That is algebra on complex numbers means addition, difference, multiplication and division. Addition of two complex numbers, take any two complex numbers z1 and z2. In general you practice also take any two complex numbers, whatever it may be, complex numbers, real part, imaginary part present, that is complex numbers. Here two complex numbers in general, z1 is equal to a plus ib, z2 is equal to c plus id. Addition of these two complex, add real, add imaginary. Here for example, z1 2 plus 3i, z2 1 plus I. z1 plus z2 2 plus 3i plus 1 plus I. Real is what? 2 plus 1 3, imaginary 3i plus 1i, total 4i. That is addition of two complex numbers. Next, here difference of two complex numbers are what? Difference of two complex numbers are what? Difference of two complex numbers. Difference of two complex numbers are what? z1 minus z2 is equal to 2 plus 3i z1 second one, difference of two complex numbers. difference of two complex numbers, that is Z1 minus Z2. Z1 minus Z2, A plus IB minus C plus ID, difference. Here separate for the real part, separate for the imaginary part. Real, A first write apply minus difference, A plus IB minus C minus ID. Real, real, imaginary, imaginary. Real part is what? A minus C plus I taking common B minus D. That is a general. Take one example. The example is what? Let Z1 is equal to 2 plus 3i and Z2 is equal to 1 plus I. Difference Z1 minus Z2 is equal to 2 plus 3i minus 1 plus I. That is 2 plus 3i minus 1 minus I. Here difference, real, real, imaginary, imaginary. This is real. 2 minus 1 is what? 1. 3i minus 1i total. That is here third one. Product of two complex numbers. Z1 into Z2, this is in general, is equal to A plus IB into C plus ID, product of two complex numbers. Then multiplication or product, write A times of this complex number, IB times of this complex number. A times C plus ID plus IB times C plus ID. Multiplication, that is A into C, AC plus I times A into D plus IB star I times B into C plus I into I square B into D, BD. Here because we know that this is value I square value, always I square is equal to what? Minus 1. I square value is what? Minus 1. That is AC plus I times of AD plus I times of BC, I square value minus 1. Minus 1 into BD. Minus 1. Separate real, real one side, imaginary, imaginary one side. Real part one side, imaginary part one side. Real is what? AC minus BD. Imaginary, when it is imaginary calling, I is present, that is called imaginary. Here I present, here I present, I taking common, remaining AD plus BC. This is the general. Take one example, that is, example is what? Z1 is equal to 2 plus 3i, and z2 is equal to 1 plus I. Addition, subtraction, same example. In multiplication also, take any complex numbers. This is the basic concept for the addition, difference, multiplication and division with one examples. Product is there, z1 into z2 is equal to 2 plus 3i into 1 plus I. Multiplication is equal to 2 times of this 1 plus I plus 3i times of 1 plus I. Simplify. 2 into 1 2 plus 2 into I 2i plus 3 into I 3i plus 3i into I 3i square, I into I square, I into I square. Here I square value always minus 1, I square value minus 1. 2 plus 2i plus 3i, total 5i minus 3, because I value is what? I square value is what? Minus 1, that is minus. Real part separate, imaginary part separate. This is imaginary, these two are real. 2 minus 3 minus 1 plus 5i. This is a complex number. 5i. That is 5. Any doubt? Product or multiplication of two complex numbers, a plus ib, c plus id. Product is there, a times of c plus id, ib times of c plus id. A into c, ac, I times of a into d plus ib times of c, ib times of c plus ib into id, I square, b into d. I square value is what? Minus 1. Yes, minus. Real one side, imaginary one side. Take one example. z1 2 plus 3i, z2 1 plus I. Product multiplication start. 2 times of 1 plus I, 3i times of 1 plus I. 2 into 1 2, 2 into I 2i, 3i into 1 3i, 3i into I 3i square. I square value is what? Minus 1. 2i plus 3i, 2i plus 3i, total 5i. This value plus becomes minus 3. Real separate, 2 minus 3 minus 1, 5i as it is. Understood? Suppose 1i plus 2i, total 3i, I plus I 2i, I plus 4i 5i. In this form, I separate, add it, and real add it. Next, fourth one. Next, division of complex number or quotient of two complex numbers. Fourth one, division of complex numbers. Division of complex numbers. In general, Z1 a plus ib is there, and Z2 c plus id. This is a common. General division form, Z1 by Z2 is equal to a plus ib divided by c plus id. A plus ib divided by c plus id. If division of complex, denominator I by apply rationalizing the function. By apply rationalizing the function, rationalization, rationalization the function. Rationalize this one, denominator rationalize, here c plus id becomes c minus id, opposite sign, c minus id. This is the rationalization. If it is rationalization, then next is what? Simplify or product, numerator, denominator. Numerator product is what? A times c minus id plus ib times c minus id. Denominator c times c minus id plus id times c minus id. Any doubt? That is very important point. Division of complex, denominator I, rationalizing the function, plus becomes minus, c plus id become c minus id, c minus id. Product of numerator, product of denominator. Next, simplify. Here a into c, what? AC. A into c is what? AC. Minus I times a into d, plus I times b into c, plus minus I square b into d. Numerator product is what? Denominator product, c into c minus icd plus dc plus minus I into I square, d into d square. C into c, c square, minus I times of cd plus I times of cd. Next, plus minus I into I square, d into d square. Because I square value is equal to what? -1. I square value is what? minus 1. Here this is I square, this is I square. Value is what? Minus 1. That is here minus I times of CD plus I times of CD get cancel. Positive negative get cancel. Numerator AC minus I times of AD plus I times of BC minus minus plus, because I square value minus 1, minus minus plus BD. Next, this is C square get positive negative or negative positive get cancel. This completely cancel. I square value minus 1, minus minus plus D square. Separate real and imaginary. Separate real and imaginary. Separate real and imaginary. Real is what? Imaginary is what? Real is what? These two are real. AC plus BD, this is real, plus I taking common first BC, first write positive, second write negative, first one write this one BC minus AD. Denominator C square plus D square. Separate real and imaginary parts. This is the division of complex numbers. Once again I will explain. Division of complex numbers: Z1 by Z2, A plus IB, C plus ID. Here, if denominator form, division is in the place, division place complex number, apply rationalizing the function rationalization. Denominator rationalization, C plus ID becomes C minus ID. Same as it is, C minus ID. Multiply numerator, multiply denominator. Numerator multiply A times C minus ID plus IB times C minus ID. Denominator C times C minus ID, ID times C minus ID. This is the multiplication process. Simplify, that is A into C, AC minus I times of ED. This is numerator multiplication, denominator multiplication. Here one value positive is there, one value negative is there, both get cancel. But keep in your mind very important point, I square value is what? Minus 1. I square value minus 1, this minus becomes plus. I square value is minus 1, this minus becomes plus. Separate for real and imaginary parts. Separate real. This is real, one side, right? This is imaginary, one side, right? But here, first one here positive right here, second one here right negative. Denominator as it is C square plus D square. This is separate for the real and imaginary. Division form, this method. Take one example. One example, that is division of complex. Let Z1 is equal to 2 plus 3i, same as it is, already 3 refer same as it is, and Z2 is equal to 1 plus I. Z1 by Z2 division, 2 plus 3i divided by 1 plus I. Rationalizing this one, rationalization method. Here division, denominator rationalize, 1 plus I becomes 1 minus I divided by 1 minus I. According to procedure, multiply numerator, multiply denominator. Otherwise, a plus b, a minus b, a square minus b square. One formula is there. This is a, this is b, this is a, this is b, a plus b, a minus b. Otherwise, multiplication. Multiplication is what? 2 times of 1 minus I, 3i times of 1 minus I. Multiplication method, 2 times of 1 minus I plus 3i times of 1 minus I. Here this denominator, that is a plus b formula into a minus b is equal to what? A square minus b square. In this place, 1 plus I into 1 minus I, value a square minus b square, 1 square minus I square. 1 square is what? 1. I square value is what? Minus 1. I square value is what? Minus 1. Minus minus plus 1. Value is what? Denominator 2. This is the method. A plus b, a minus b, a square minus b square, 1 square minus I square. Because I square value is what? Minus 1. That is equal to, simplified, denominator 1 plus I square value is minus 1, minus minus plus 1, denominator 2 into 1, 2, 2 into 1, 2, that is minus 2i plus 3i plus minus minus 3i into I, 3i square. I square value is what? Minus 1 is equal to, here denominator is 2, 2 as it is, minus 2i plus 3i. I square value is what? I square value is minus 1, minus minus plus. Real, real, imaginary, imaginary. Real, real add it, imaginary, imaginary add it. Real part, separate real, separate real and imaginary. Real part is what? 2 plus 3, value is what? 5. Imaginary, total how many eyes? 3 eyes. Here total how many eyes? Minus 2 eyes. 3i minus 2i, total 1 eye. Divided by 2 is there, right? Separate or equal. That is the example with include here division of complex numbers. Very important for division of complex number, carefully. That is z1 by z2, 2 plus 3i divided by 1 plus I. This division of complex, rationalizing the function, 1 plus I becomes 1 minus I divided by 1 minus I. Here if suppose in this place minus is there, plus, plus is there, minus, that is the rationalizing the function. Denominator a plus b, a minus b formula, a plus b, a minus b, that is a square minus b square. 1 plus I, 1 minus I, 1 under 1 square, I square, b square replace I square. I square value minus 1, minus minus plus, that is denominator 1 square plus 1 square is there, that is 1 plus 1 is 2. Product of numerator 2 into 1, 2, minus 2i plus 3i minus 3i square. Here in this place I square value is what? Minus 1, minus minus plus. Real part one side, imaginary part one side. 3i minus 2i, total 3i minus 2i, 1i. Yes, this is 1i. In this place, real part is what, imaginary part is? Real part is 5 by 2, imaginary part is 1 by 2. This is complete complex number. Both meaning same. Alright, this is also same. Both meaning same. 5 plus I divided by 2. Suppose question asking, write real and imaginary part of this. Real part is what? 5 by 2. Imaginary part is what? 1 by 2. Real part is 5 by 2. Imaginary part is 1 by 2. Next, that is here basic concept for the complex number is complete, basic concept. Next, for start exercises in 5.1 next class.